Alright, pause, pause the video, give it a go first yourself. Okay, same as before really in terms of exercise. Initialize index register to 0. Well, by looking at what we've got to do, which one is involved in putting something into the index register? Well, it's LDR. So, sorry, my pen I thought was ready to go, but it's not. LDR, and we're going to put into it hashtag 0. Get the first character of word, so we need to actually load up the index register, LDX, to access it. And what we're dealing with this string, you can say. Remember what we looked at last time: 0, 1, 2, and this time 3. So LDX of word, which would be this first value here, B011, blah 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 blah. Now I'm going to skip this line for now, but we will come back to that in a second. We are going to output, so I'm just going to do out for output, because we're going to output the character to the screen. Great. We're going to increment the index register, so that's easy. Inc IX. Okay, we're then going to load 1 into the accumulator. So what we want to do is load a number into the accumulator, so i.e. being 1, and it's LDM which does that. So LDM, and we're going to do hashtag 1. We're then going to store that in count, so we're going to store whatever's in the accumulator into count. So STO count. Load the next character, so this is going to be within our loop. So we need to do LDX word, make lowercase, so I'm going to come back to this one, making the lowercase, output character to screen, out. Okay, we then want to increment count. So how do we do that? Well, first of all, we need to put count into the accumulator. I discussed it in the last video, so it'll be LDD count. We then want to increment whatever's in the accumulator. Remember I said that last time. So that would add 1 to the accumulator. We then need to take the value, whatever's in the accumulator, and store it back into count again. We then want to do a comparison. So is count equal to length? So we need to use compare. And we want to check to see if it's equal to length. So we're going to do length. But I'll take whatever's in the accumulator and and compare it to the length. Now, if false, so if you look at our if statements are jumping, we need to use JPN. We need to then jump back to the start of the loop. We then have our end. Count needs to be starting at 0, which makes sense. In fact, we would put, we can put it into here, really. Okay. There we go so far. That leaves us with actually having to use mask 1 and then mask 2. The issue is that there's no mask to use. We have to create the mask ourselves. In a previous video, we were given the mask to use, and we had to choose the whether or not we're going to be using an and or not. This time, we're aware of the following. It tells us what's lowercase and what's uppercase, and we'll notice for lowercase it has 0, 1, 1, for uppercase 0, 1, 0. So if we go back to having to ensure it's in uppercase using mask 1, remember, it needs to make sure that the first character is in uppercase and the rest of it is in lowercase. So if we have right now apple, this first comparison here will just check the first letter every time. The second time, which is here, it will check in a loop for the rest of our characters. One's to make sure is in uppercase, the other is to make lowercase. So let me just undo this. So what we're going to do is we're going to take the first letter, which is 0, 1, 1, 0, 0, 1, 1, 0. Pretty simple so far. Now, we want to basically convert this into uppercase. So really we want the end goal to be 0, 1, 0. We don't really care about the rest. Because this is different to the last time, because the last time, if you remember, it checked it, it gave us a new value, which was for green, it then added it to the accumulator temporarily, it then, which basically then reloaded the value back into the accumulator of a word, because we were checking to see if it was uppercase or lowercase. If it was uppercase, fine. If it was lowercase, it would get converted. This is simply just going to convert it if it's not uppercase. So, what do we need to do to put here to give us the end result of 0, 1, 0? Now, if we were to, we definitely did a 0 here no matter what. Now, if we were to put a 0 here, and we were to put a 0 here, and just fill these up with zeros, that won't be it, and we were to use AND. That won't be appropriate because 0, 0, 0, 1, 0, that will give us an actual 0, not a 1. Now, if we were to use or, so let's just focus on these three, remember. If we were to use or, great, so we've got 1 or 0 will give us a 1, 1 or 0 will give us a 1. So we can't possibly use that as our calculation of 0, 0, 0. Now you could say, why don't we use XOR? Will that work? Well, it might do. Let's have a look. 0 XOR 0 is 0, 1 XOR 0 is 1, 1 XOR 0, that'll make this all 1. So no, we can't. So what other options do we have? Well, let's fiddle about with these three numbers again. So I'm just going to erase these numbers. And this time, we know that this is definitely going to be a 0, so let's just put the 0 in. Now, let's just put a 1 here. And let's put a 0 here. Okay, and let's imagine that we used, to begin with, OR. So I'm trying to get, there you go. 0 or 0 gives us 0, great. 1 or 0 gives us 1, 1 or 0 will give us 1. That won't work. We know that XOR won't work because of 1, 1. So let's try AND. 0, 0, 0, perfect. 1, 1, 1. 1, 0, 0. Perfect. So you could say, job done. But no. Job isn't done. And I'll go back to why it's not done at the end once we've done lowercase. But for now, I'm also going to delete these zeros. Oops, didn't mean to do it that much. So let's try that again. Let's just delete, 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 delete. Okay. Now, I'm going to replace those zeros with ones because having a 1 isn't going to have an impact on the original letter, as in this value of it. Whereas if we had it as a 0, and we ANDed with this, so we have these as zeros, it would change the original value to be zeros. Whereas actually, if we have them all as ones, 1 at 0 is 0, so that doesn't change, that doesn't change, that doesn't change, that doesn't change, that doesn't change. So our mask is complete up until this digit here, which I will go over for lowercase. So, for mask 1, I'm going to put in 1, 0, 1, 1, 1, 1, 1, but with a mystery character there. Now for lowercase, the mask would be the inverse of the uppercase. And so the mask 2 should be the inverse of the mask 1. So mask 1 was 1, 0, 1, 2, 3, 4, 5, and we had our mystery guest there. And if we flip it, it would be mystery guest, then 0, then 1, and then all of these are zeros. Now the end result of these calculations should give the numbers being the same, so 0, 0. If we used AND, 1 and 0 gives you 0, so we can't use AND. So let's try OR. 1 or 0 gives you 1. 0, 0, 1. I apologise, I wrote out the number wrong. Oh no, I didn't. It should be fine. 1. Sorry. 1. Which, if we look at this, that will be correct for a lowercase. So we want this to be 0. Now, if our mask was on the previous mask, if that mystery figure was a 0, then this would have to be a 1. And as we're using OR, this would be a 1. Therefore, that would be incorrect. If our mystery guest figure digit was a 1, then this would be a 0, which would be correct. So if we go back to the, this would be our correct mask for mask 2. This would be our correct digit for mask 1. So if we were to actually go back to mask 1, where we've got this, by having a 1 here as our mask, it's not going to make any difference to this number. So that'll be a 0, that'll be a 1, that'll be 1, which is exactly what we need. But it will help us with dealing with the second mask and the OR. So overall, there we go. Now finally, it would be very useful if we were to fill this in. So for mask 1, we had to AND it. And for mask 2, we had to use OR.